Why would you come to mechanic class without touch, bro? That's like coming to.
A lot of people claim to be the first one that it patented the idea of the spark plug, and they went as far back as the late 1800s with Robert Bosch. You ever heard of him? Mm-hmm. Yeah, they make Bosch, all kinds of Bosch stuff, fuel injection parts and everything else. You never heard of Robert Bosch, then you haven't ever worked on cars, hardly ever. Everybody heard of Robert Bosch. Robert Bosch and Albert Champion had a couple familiar names, and there was even a patent submitted by Colonel Lee Guinness of the Guinness Brewing family. All right, so Rocky Road. Albert lost the Champion Ignition Company founded in Flint, Michigan to investor drama. Well, after that, he was renamed president of AC Spark Plug Company, formed with a backing from Buick. And Buick was named after David Buick, who came over here from Germany because he knew how to make ceramic bathtubs. So, and maybe one Buick looks like a bathtub, who knows? All right, so who gets the credit? You know, Robert Bosch tasked the Gamma, can you say the German name? With engineering magneto ignition system based on what was then known as electric arc ignition. And that was credited with making a modern spark ignition engine a possibility. Now, you can take a crank telephone. When I was a boy, there used to be one of these in just about everybody's smokehouse. I mean, you know, have a smokehouse, and by the time I came along, they weren't smoking meat anymore because we had refrigerators. And so the smokehouse was somewhere you put junk. And the old telephone was there, and you could take one of them things right there, there's a bunch of magnets right there, and when you turn that crank, that thing would spin inside there and produce electrical current. And what the old trick was, if nobody had ever seen one of those before, you'd say, hold these two wires while you turn the crank, and they just light them up good. People would take those out on a boat, and they'd throw the two wires in the water, and they'd turn the crank, and fish come floating up to the top. I mean, that's how much juice and things would put out. There's your magneto ignition system. You see it looks like a distributor up there. The little where the spark plug wire connected to it. Now, no engine's going to run without the right amount of homemade light in it. It takes a lot of voltage to punch through plain old atmosphere, let alone tightly packed molecules in the combustion chamber. Now, the fuel droplets in the combustion chamber help to conduct that. That's one of the reasons that you see this little upkick right here. Whenever this fuel is all burned up, you get some more resistance, and then the spark goes away, and you get leftover ignition. It's kind of like snapping a rubber band right here. If you don't see this coil insulation on your scope pattern, and you've got typically a coil that's weak, or there's not enough voltage going to it, or something like that. Now, the gasoline molecules provide the current path. You go away and out with the oxygen. Now, the pop of the ignition spark in the open air is like lightning. Is basically what it is. It's thunder on a tiny scale. Since the stream of electrons in an ignition spark displaces air molecules the way lightning does when it stabs through the air in a thunderstorm. So when you hear a spark go pop, 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 you know, that's like whenever you see the lightning and then you hear the thunder. That's the same deal. It's just on a bigger scale. All right, so how do we make it? So we got an output terminal here that makes this spark. And the way that it happens is you got B plus going in here, and you got from the pointer to the module. And whenever you saturate this primary coil, which has only got like 100 wraps, and this one here's got like 1,000,000, and whenever you take that 100 wraps and you take the voltage in there and you multiply it by the number of wraps you got in here, when you make that connection and it saturates this in this iron core with magnetism, you might notice whenever you break the points or you know, and this saturation collapses, it causes a huge sweep across all these little tiny windings, and this spark comes out of there and it will fire you up. You know, anybody's ever been with a, Donnie was over working on one of these, you know, the little Escort we got over here? Whenever it's idling, and also the Crown Victoria, when it's idling, it's popping like 3 times instead of just one. The spark plug's not going pop, 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 it's going buzz, buzz, buzz. Now when you crack above an idle, that goes away. He's working on this Escort one day, and I walked over there and I said, what are you doing? He goes, I got a misfire over here. And I said, I got this spark plug right over here. And he reached over there, about the time he reached over there, that thing fired him up with this buzz, buzz, buzz. And he kicks the fender with his knee. Whoo, bam, hits his hip. Oh, and he looked and the fender was bent, and he says, did I bend to that? You know, he was just all rattled because this thing got me popped him good. You got to be careful though. If you're leaning on that and it runs across your chest cavity, it can stop your heart. So don't horse around with that stuff, it ain't no fun. You can actually ground, use a wrist strap like the computer people use, and ground that somewhere. So if it does shock you, it'll go in through that wrist strap and it won't come anywhere else. You been shocked by a plug wire? What does it feel like? It feels like all your muscles are going at the same time and you can't do anything with it, you know. What about you, Nick?
No.
Your day is coming. All right.
Yeah. Don't waste it
We'll
on
make a lot of it here. Magnetism induces voltage in copper. You know, like I told you, wrap a bunch of copper wire. You know, this copper, like in these little motors, see that little motor wire? These motors, see, that looks like plain old copper, but it's actually coated with some shellac stuff. So these wraps, this wire is wrapping, but it's not touching each other. None of the wraps is touching each other. So the current is forced to follow that wire all the way around. But if I take that wire right there, and you can get a magnet wire, I got a roll of it out here. Wrap it up, wrap it up, wrap it up, and hook a meter to it, and you run a magnet through that little loop of wire, you're going to see the meter showing voltage, because you're creating voltage, what you're doing. And a voltage spike, really powerful and useful, you control it. Now your distributor, the way that works is this rotor spins around and sorts out the spark. It pops one time for every cylinder, and it spins around, and every time whenever it pops, it needs to be pointing at the right cylinder, because you know, the piston's got to be at the right place, and it's got to be on a compression stroke and just before top dead center and all that when it fires. That's why when you turn this distributor to set the timing, you're changing the relationship between this and this. And that's causing that coil to fire at a slightly different time, but it's also causing your spark to happen whenever that rotor is in the appropriate place for it to go out. Just remember that. All right, you're going to make this here. There's your points right there. You got your ignition points, and your condenser is like a little, you know, condenser is like a little battery that stores current really for a very short period of time. And they've got them sometimes on these big old air conditioning units. They'll have one here, and it basically dumps a bunch of juice in there to kickstart that compressor and get it going. Well, this right here is going to help that coil be hotter, so it's going to charge the coil up quicker, you know, than it would if it didn't have a condenser. If you got a bad condenser, you'll have issues like that. So what you got is, every time that ground happens, the guy, that primary winding I was talking about, and your secondary winding, and going to the spark plug, it's a nice little thing. Two sets of points on some of the older hot rod distributors will extend coil saturation time, because one set of points closes, the other set of points closes, this one opens, and then that one opens. So you can basically, you know, have more dwell, and dwell is how long the points are closed. You might remember that. The amount of distributor rotation where the points are closed, that's what dwell is. So you got to remember that. Winding one is the primary winding, and the ground side of the ignition coil primary round is switched on and off by contact breaker points. On your old MSD, those actually would switch the hot side. The MSD ignition, some of them were the ones that I dealt with. All right, 6 cylinders have 6 bumps. See the little bumps in the distributor? And every time it opens those points. Whenever you're going to set the points on a vehicle, if you're doing that, what you would do is you would put the little rubbing block right there on top of that bump. You notice there's grease on it, so it will wear out. And then you're basically going to have to turn that. You loosen that screw and you turn that screw, and it's like an eccentric screw. And it actually moves this so that you're setting a gap on those points. You could do it with a filler gauge. It's best to do it with a dwell meter. You know, but it's basically going to be roughly the thickness of a matchbook cover for the most part. You know, the distributor on these archaic old systems rotates at camshaft speed, which, you remember, your camshaft only turns half as fast as your crankshaft. On the other end of this distributor was the oil pump drive. Typically, that's the way that works. Now, some of them, it's got a distributor on the end of the camshaft. They don't drive the oil pump; it'll be on the end of the crank. But long and short of it is, on older ignition systems, they open once each cycle per cylinder, 4 times for 4, 6 for 6, and so on. Now, points are gone. It's a good thing too, because you know, when I first started working on cars in the early '70s, points were all over the place. And the first thing you did, if you had one that wasn't running right, you pulled the distributor cap off, you found something wrong with the points. Well, the old timers, we all got used to that, and we were really happy with it because we understood it. You see what I'm saying? And it wasn't all that difficult to throw points and plugs in it, unless it was one of those GM cars that the points were buried way back in the back under the firewall, close to them Pontiac and all that. Bad news or Chevrolet. The distributor's up front, like on a Ford, wonderful. It's right in front of your face. Real good. This is a reluctor, and this is a little magnetic pickup. And whenever you turn that through, you know, this magnetic pickup, the magnetic field shifts, and it's going to cause a little signal. It's causing an electronic module. You see me go through this ignition board over here, right? Remember that? Remember that. This little thing here represents a transistor that it used in lieu of the points. And so, and then your distributor cap. This coil is an oil-filled coil initially when they first started doing that. And so, a lot of the times your coil will have a ballast resistor in series in between it and the ignition switch. So it would crank on 12 and run on 8. The little starter relay would have a little ignition terminal that went over to the ignition coil and bypassed the ballast resistor when you were starting it, so you'd have a hotter spark. Now, GM's HEI came out in 1974, And that's kind of what we got on this motor out here on the stand with that particular vintage. And this is fairly ignitional, I mean, simple wiring. This right here fires up that and the coil. And this right here trigger, fires the coil. And these right here are the ones that come from your pickup coil. Now on this one right here, you can basically, and I showed you that on that board over there, if you've got your key on and a way to check your spark, because the coil's in the cap, you got to, set a test light or something up so you can be holding it over so it'll jump in that. And you can touch the positive battery terminal on one hand, and with these wires unplugged, tap those two terminals with the other hand, they'll fire the coil. This thing right here is basically going to think you're the pickup coil when you do that, because all it's looking for is a tenth of an amp, and that goes through your body anyway, as long as you're touching the battery terminal on the other side. I can show you that on that 350 engine out there, if you're at all interested in that. Whenever you replace one of the ignition modules, you always make sure you put some dielectric grease on there. Tim, pay attention. Put some dielectric grease under there so that the heat will actually be carried out. This little module gets blistering hot. If you don't put the dielectric grease on it, you're going to burn the sucker up. It ain't going to last till the water gets hot. Alright, now this right here is Ford's DuraSpark, came out in '75. Switch ground came from the module. You basically had you had this orange wire, you had your purple wire, those were coming from the pickup coil. And they go into this module, and that module right there is going to respond to that signal I showed you a while ago. And this is, hot and start, hot and run. The red's hot and run, the white's hot and start. Fall primary. On my pickup that one day, when I was driving my pickup, I had one of these kind of ignition systems, an old 80 model Ford pickup I had for a while. And I noticed one day I pulled out and it was running terrible. And I remembered I'd seen a lot of this stuff, potted material running out from under the module that had gone down the fender, like the module was trying to die. And it was running terrible, and so I turned the key just slightly past the run position to start position, and I fired up this white wire when I did that, and it ran good. When I let it back to the run position where it was the circuits in here that was fed by the red wire, it ran bad. And so I had to have one of those modules. That's another story when I went to the parts house and bought one. That's hot and run, switch from the ground side. Chrysler 72. On this one here, you had a dual ballast resistor on your battery, your switch. And basically, this is your little pin out over, I got on that board over there. Your distributor, you can actually just short those two together with your screwdriver. That's one of you gets to check these. I would actually take this and I'd short those two wires together to see if that coil would fire, as I know if the module is good or not. The module looks like that. This is the transistor right here. And so you got 5 ohms and half an ohm there. And all right, so here's the pop test. Ready for pop test? What's happening at point F? Coil saturation. Can you write that? Can you write that? Coil saturation. If you write it down, you're more likely to remember it. If you just sit there and it's like, don't you love to love a fill in the blank test? Don't you do? Michael Cross, you're supposed to have one of these too. What are you doing over with that one?
I had a phone call from my doctor, so I couldn't use class all
That's
week.
no excuse. You should still have a sheet. All right. So right here is you got right here. Whenever you've saturated your coil, and if you've got an ignition module system, it's going to stop feeding current in there and hold it there. And this right here is when your point's open. When your point's open, it's your firing line. When your firing line, if you got a firing line that's taller than all the rest of them, you got extra resistance in that circuit. All right, now this is your spark line right here. So the firing line and how tall this is going to tell you, like if you stretch the spark. Have you ever stretched your spark on a plug wire where it's going pop, 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 pop? When you do that, this gets taller. If you short the spark out so that it ain't got nowhere to go, like if you just short it directly to ground, this gets shorter. So this is going to have a lot to do with how much energy it takes to jump across. Now when it starts burning, you're basically, this is how long the spark stays there. So remember, this is voltage over time. So this right here, if the more that goes out this way, the less can go up that way. Right? And so the more it goes up that way, the shorter this is going to be. If it takes more to do this, you use up some of what it takes to do this. That B, the spark line, that is how long the spark stays there. That is the spark line. And I've actually got a tool in there, that's from General Technologies that I got, that GT505, that you can actually watch that on the ignition system. Now look at this. Well, that upkick means your fuel's burned out, right? And then the spark burns out, and this is your leftover energy. You got it? So what's happening at point A? It's when the spark plug fires. It's when the spark jumps across the plug gap, right? Burn that in. This is for you to learn.
C is saying when it starts, right?
All right. That's what's happening at point A. What's happening at point C?
Just when it starts.
That is actually the beginning, that's the amount of voltage in the spark line, and this is how long the spark line stays there. So see, it takes a lot more to jump the gap than it does during the burn. You got it?
So it's the amount of voltage.
Yeah. The amount of voltage in the spark line. This is the firing line. This is when it first pops, and this is the amount of time that the spark is burning when it's going. Now, like I say, on the escorts, you'd see more than one firing line because it goes pop, 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 you know, like that. Yeah, don't go stick, Tim. All right, and there's your bead.
Spark line.
That's the timing. This is measured in milliseconds. And how long is 1 millisecond? Thousandth of a second. Got it? Millimeters, a thousandth of a meter. Milliseconds, a thousandth of milliliters, a thousandth of a liter. Got it? All right. What's the reason for the bump at point D?
That's when you burn out.
When the fuel is used up. That's exactly right. Hydrocarbons have been united with the oxygen by that point. And what's the reason for the point E at squiggle?
It's the
Leftover energy. Okay, now you guys, in one short session, you've had a quick rundown on spark pluggery, ignition systems, and you ought to know how to read a spark pattern. And if I plant a bug, or you're doing your final exam, because you know you got to do, on your engine performance, you're going to have to do 4 engine performance finals. All of them are different, except for Tim, I got to give him 6. Okay? That's right.
When do we do the certification test?
Huh?
When is that certification
The
test?
certification test is, you know, when I feel like you guys are ready for it. And that's probably going, it's going to be the next week or two. You know, I've already got the credits up there. All right. What happens to B when A goes higher? When A goes higher, what happens to B?
It stretches out.
It gets shorter.
No, I thought you just said
When A goes
No, when A goes higher, B gets shorter.
Yeah.
So if A is shorter, B will be longer. It's like being a piece of string, man. You know what I mean?
Okay, that makes sense.
Think about it. When this goes high, they get shorter. This gets shorter when it gets longer. So this gets shorter this way when it gets longer. Now, one time when I was working at a Volkswagen place back in the day, I had one that was a Volkswagen. It was Rabbit that was running. It was a gas burner, and it had K-Jetronic fuel injection on it, and it was running really crappy. When I would get on it, it would go just sputtering and popping and cutting up. And I rolled the scope over there and I hooked it up to the ignition system. I'd used the scope a whole lot back in 1983, you know. It was crazy, that was a long time ago. Right? But anyway, I noticed that this line right here was just going really crazy. I mean, it was just really going wacky when I rev it up like that. And what I found out was the fuel filter was stopped up. What was going on with it, didn't have enough hydrocarbons here to have a good steady burn. Now, Mac Vandenbrink is a guy that has done so much of this scope stuff. He can look at a scope pattern and show you when your camshaft load's rounded off. I mean, he's got some of the best stuff on scopes I've ever seen. I wrote that article called Scan Tool Scopes and Toothpicks for that, where I fought with that Jeep for a week and found out, and I finally got it set using a scope to set to, you know. Anyway, and I said, my closing article was all this, I spent a week fooling with this thing and I could have fixed it with a toothpick. And literally, I could have fixed it with a toothpick. And he sent me a copy of one of his presentations and a toothpick when he read that in the magazine. It was pretty funny. What does it mean if there's no squiggle at E? If it just dips down.
There's no leftover energy.
Weak ignition coil. Weak ignition coil. You know that? What happens to B if A is shorter?
It gets longer.
It gets longer. What determines the height of A? Needs to be an intelligent answer now.
The strength of the spark.
The actual amount of resistance in that particular ignition circuit. You got a burned out spark plug wire. And if you got a spark plug, it's wide open on the inside. Or if you got a plug wire that's actually been left off. Do that. And huh? All right. Are y'all happy with that? Is it good?